The procedure for doing a truth table for an argument is pretty much the same procedure as doing a truth table for multiple statements. The only difference in the procedure for creating a truth table for an argument is that you use double slash marks to separate the premises from the conclusion when you write out an argument. Also, unlike a truth table for multiple statements, you can use the truth table for an argument to determine whether or not the argument is valid. Okay? So let's look at an example of an argument. So here's an example of an argument, and we're going to go from the argument given in ordinary language to setting up a truth table for this argument and using the truth table to determine the validity of that argument. Okay? So this argument states, if Superman is the best movie ever made, then Batman is not the best movie ever made. So since Batman is the best movie ever made, it follows that Superman is not the best movie ever made. Now, one of the first steps that we want to do when we have an argument is to identify the premises and the conclusion. We can do this for this argument by identifying the premise indicators and the conclusion indicators. Notice here you have so, and so is a conclusion indicator, okay? And here you have since, and since is a premise indicator. Then here you have it follows that, and it follows that is a conclusion indicator. Now, you also have here a comma, okay? So this comma tells us that this so is indicating that the conclusion is not what is inside the comma, but the statement that comes after the closing comma, okay? Which is actually this statement here. So these two conclusion indicators are actually indicating that this statement here is the conclusion. So I'm going to identify this statement here as the conclusion by labeling the statement C. Okay? Now this is a premise indicator since, okay? And it's telling us, because there's no comma here or anything, that the statement that immediately follows it is a premise, okay? So this statement here, Batman is the best movie ever made, is going to be a premise. And I'm going to label this as a premise by putting P. Okay? Now that we've identified these two statements here, one being the premise and one being the conclusion, we can also say that this statement here is a premise as well. Okay? So I'm going to label that with a P. Why? Because we've already identified the conclusion. Okay? And we're assuming that all the statements here are relevant statements. Okay? Okay. So now that we've identified all the premises and the conclusion, okay, we want to go ahead and translate each of these statements, okay? There are three statements here, two premises and one conclusion, okay? So this is actually a syllogism. We want to translate each of these statements into propositional logic, okay? We're going to work with one statement at a time. So let's start with this statement here. Remember, what we want to do is first identify the simple statements that make up the statement, okay? And then identify the logical operators. Here we have the statement, Superman is the best movie ever made. Okay, so that's the first simple statement we have. We're going to give that simple statement the propositional variable S. Okay, then here we have Batman is, the best movie ever made. And we're going to give this simple statement the propositional variable B. Okay? Now that we've given both these simple statements letters, okay, we can identify the, so now that we've given both of these simple statements letters, we can identify the logical operators that make up these statements, okay? Notice we have an if over here, and then we have a then over here. So these two words, if then, go together to indicate one logical operator, which is the conditional horseshoe. And that conditional horseshoe goes where the then goes. So we're going to go ahead and put the then there. We also have the negation operator here indicated by the not. So we're going to put the tilde, which is the negation operator, right there above the not. Okay? So for premise 1, okay, we have S, horseshoe, tilde, B, okay? And notice that this is a well-formed formula, okay? There's nothing wrong with this statement here grammatically, okay? Now we can move on to the next statement. So the second premise here states Batman is the best movie ever made, okay? And because this statement as well as the conclusion belong in the same passage with this statement here, And we've already given the statement, Batman is the best movie ever made, a propositional variable. We're going to use that same propositional variable when we come to this statement here. Notice here we said, Batman is the best movie ever made will be B. So Batman is the best movie ever made here will be B as well. This tells us that premise 2 is going to be simply the statement B, okay? Batman is the best movie ever made, okay? Now what about the conclusion? The conclusion states that Superman is the best movie ever made, okay? So once again, we've already given the statement Superman is the best movie ever made a propositional variable. We've given it the propositional variable S up here. So we're going to use that same propositional variable here, okay? And notice here we also have the logical operator negation that's indicated by the not, okay? And so we're going to replace the not with the tilde, which is the logical operator for the negation, okay? So for the conclusion, we have the statement not S, okay? So here we have 3 statements now in propositional logic, the 2 premises and the conclusion, okay? Now that we have the statements of the argument written in propositional logic, we can set up the truth table for this argument, okay? How would we do that? Well, we go ahead and write out the premises as well as the conclusion across like this, just like we would groups of statements. However, in between the premises and the conclusion, we add a double slash mark, whereas in between the premises, we add a single slash mark. This indicates to us that this premise ends here, and this premise ends here, and what follows this premise is the conclusion, okay? And when you do a truth table for an argument, it's very, very important that you put the conclusion last, okay? Very important that you do so. If you don't do so, it's going to be a little bit more difficult when you try to determine validity, okay? So always try to put the conclusion of the argument last, okay? So we've labeled each of these statements, P1, P2, and the conclusion, and we've also identified the main operator for this statement. So here we have the horseshoe being the main operator. Here we don't have a logical operator, so we simply have the B marked, okay? And then here we have the negation marked as the main operator for the conclusion, okay? So notice how here, among these statements, we also only have 2 distinct variables, okay? So we have an S and a B. So because among these 3 statements we only have 2 distinct variables, we only need 4 lines, okay? Because number of lines is 2 to the n power, n equals the number of distinct variables. So here we have 2 to the 2nd power, which is 4, okay? So we have 4 lines, okay? And we went ahead and set up the columns and so on and so forth. So now, just like we did with the single statements and the group of statements, the next step that we want to go to is to give the initial truth values for the distinct variables, okay? So the first distinct variable we come to here is the S. So we're going to go ahead and cut the column in. We're going to go ahead and cut the lines in half and give the first half all true and the second half all false. And that's what we have. Then we have here the second distinct variable, which is B, and we're going to cut the halves in halves, which means we end up with quarters, and alternate every quarter, true, false, okay? And then here we have B again, so we're simply going to take the truth values we gave to B already and put them in here, okay? Then we have the S here again, so we're going to simply take the truth values that we gave to S already and put them in here, okay? Now that we've done so, notice that we immediately have the truth values for premise 2 already. Why? Because premise 2 is a simple statement. It's the simple statement B, okay? So we don't have to worry about determining the truth values for premise 2 anymore. What we have left, however, are the truth values that we need to determine for the rest of premise 1 and the rest of the conclusion, okay? So let's start here. Now remember, we want to start with the smallest components parts, move our way out, saving the logical operator, that's the main operator, for last, Okay, this statement here is a conditional statement, okay, indicated by this star here, which tells us that it's pulling together this as one of the main components and the S as one of the main components. So we need to determine the truth values of the parts first before we do the truth values for the main operator, which is a horseshoe, okay? We already have the truth values for the S, so now we're going to have to determine the truth values for the not B. Okay? So again, this is a negation, so we're going to use the truth values for the B, the statement that it's negating, and the truth function of the negation operator, okay? And that will give us the following truth values, okay? Then, after we've determined the truth values for the component parts, okay, we will do the truth values for the horseshoe, okay? And the horseshoe, because its component parts was the S as well as the negation B, we're going to use the truth values for the S and the truth values for the negation B, which is actually under the negation, okay? So using these truth values here and the definition of the truth function for the horseshoe operator, we have these truth values, okay? So now we've done the truth values for this statement, okay? Let's move on to the conclusion, okay? So here is the conclusion here, and notice how the conclusion is simply the negation of S, okay? So all we need to do is determine the truth values for negation S. So we're going to use the truth values for S and the truth function for the tilde, okay? And doing so will give us the following truth values, okay? Okay, so now we've done the truth table for the entire argument. Notice that the procedure was basically exactly the same as doing truth tables for sets of statements. The only difference is that we've differentiated the premises for the conclusion by putting double slash marks here between the premises and the conclusion. Also, you want to make sure to put the conclusion last at the end, okay? Okay. Now that we've determined the truth table for the argument, we could actually use this truth table to also find out properties of each of the individual statements, okay? How is that? Well, this is the column that represents all the possible truth tables that this statement can have. And notice how in this column you have both false and true. So this premise here is contingent. So premise 1 is a contingent statement, okay? This column here represents all the possible truth values that premise 2 can have. And if you look here, you notice that premise 2 can also be true as well as false, okay? So premise 2 is also contingent, okay? Then finally you have the column for the conclusion, and that's this one here under the main operator for the conclusion, which is the negation tilde, okay? And notice this statement as well can be false and true, okay? These are the possible truth values that this statement can have. So this statement as well, the conclusion, is contingent, okay? These are properties of each individual statement. We can actually also compare the statements together as well. If you look here, okay, it's not the case that every time this statement here, premise 1, has a certain truth value, premise 2 has the opposite truth value. Why? Because although they do here, okay, they don't over here. So where this is true, this is also true. So these are not going to be logically equivalent statements. They're also not going to be contradictory statements. So notice here, every time this statement, premise 1, has a certain truth value, it's not the case that premise 2 will have the opposite truth value. Why? Because although they do here, okay, they don't over here. So where this is true here on this fourth line, this is also true. So these two statements, premise 1 and premise 2, are not contradictory statements, okay? It's also the case that they're not logically equivalent statements because although these statements, premise 1 and premise 2, have the same truth values here, they have the opposite truth values in lines 1, 2, and 3. So these two statements are also not logically equivalent statements, okay? However, they are consistent statements, okay? Why? Because there's at least one line in which both statements are true, here and here, okay? So these are going to be consistent statements, okay? So premise 1 and premise 2 are consistent, okay? Now you can also use this truth table to compare premise 2 with the conclusion, as well as comparing the conclusion with premise 1. But I'm not going to do that here, okay? What I want to do is move on to determining the validity of this argument. Now when you look at this argument, in order to determine the validity of an argument, you want to see if you can find a line where you have all true premises, okay, so where both premises are true, but the conclusion is false, okay? So notice that the only line where you have all true premises is here, okay? But where you have all true premises, where both the premises are true, the conclusion is actually true, okay? So you do not have a line then in this truth table for the argument where you have true premises and a false conclusion. Because that's the case, this argument is valid. Okay? So the way that you determine the validity of an argument using a truth table is to look for at least one line. You might have more than one, but look for at least one line where the argument has all true for the premises and false for the conclusion. If the argument does not have any such line, then the argument is valid, okay? But if you can find at least one line where there's all true premises, where each of the premises are true and the conclusion is false, then the argument is invalid, okay? Let's look at another example. So here we have the example, if Socrates was human, then he was mortal. Socrates was mortal, so Socrates was human, okay? Now again, we want to ask, what are the premises and what are the conclusion? Notice here we have the conclusion indicator so, and there's no comma or anything, so that tells us that this statement here, Socrates was human, is the conclusion. So I'm going to go ahead and mark that as the conclusion here, okay? Also, we can say that by elimination, as long as these both statements are relevant, this statement here is a premise, so premise 1, and this statement here is also a premise, so premise 2, okay? So this is actually a syllogism. It has two premises and one conclusion. Okay, now we want to identify the simple statements that make up each of the statements, okay? So here we have Socrates was human, and we're going to give that the propositional variable h, okay? And here we have the statement, he was mortal, which stands for Socrates was mortal, so we're going to give that the propositional variable m, okay? Now what we want to do is identify the logical operators. So notice here we have an if, and here we have a then, and that's it, okay? Which means that the if and then is telling us that there's one logical operator being used, which is a conditional horseshoe, and that goes right here where the then is, okay? So then premise 1 is H horseshoe N. And notice how this is a well-formed formula, okay? So now we go to premise 2. Premise 2 simply states Socrates was mortal, okay? And we've actually already given this statement, Socrates was mortal, a propositional variable. We gave it the propositional variable here, M, okay? He was mortal stands for Socrates was mortal. So we're going to give this statement here the same propositional variable because it's given in the same passage as with this statement, okay? So premise 2 will be the simple statement M, okay? And then now we have the conclusion Socrates was human, and here again we've actually given this statement a propositional variable already. We gave it the propositional variable H. Okay, so Socrates was human was given H. So we're going to give that same variable to this statement, which is the same statement. Okay, why? Because it's given in the same passage as the statement here. Okay, so the conclusion will be H. okay? So now that we've translated the statements into propositional logic, we're going to write them out in order to set up the truth table, okay? So we put premise 1 here, premise 2 here, and the conclusion here, okay? Always put the conclusion last. And then we set up the truth table. We've determined how many lines we will need. We only have 2 distinct variables here, so the number of lines will be 4, okay? And we want to go ahead and do the initial distributions of the truth values. So here for the first distinct variable h, we cut the number of lines in half, okay, and give the first half true and the second half false. Then for the next distinct variable, we cut the halves in half, so we have quarters, and we alternate starting with true, okay, the quarters true, false, okay? And then we have m here as the next statement, and we've already given truth values to m here, so we're going to use the same truth value here, okay? And then we have here the conclusion, which is h, which we already have given truth values to h right here, so we're going to use the same truth values here. Now, by doing so, we've already determined the truth values for the premise 2 and the conclusion. Why? Because premise 2 and the conclusion were just simple statements. Okay? However, we need to finish the truth table by giving the truth values for premise 1, which is a conditional statement. And because it's a conditional statement, we're going to use the truth values for its component parts, which is the truth values for h and the truth values for m, as well as the truth function for the horseshoe. Okay? And that will give us these truth values. Okay? Okay. So now that we've done the truth table for the entire argument, okay, once again, you can figure out properties of the statements as well as relationships between the premises, the conclusions, or among the premises, okay? However, I don't want to worry about that here. I want us to try to see if we can figure out whether or not this argument is valid or invalid. Now remember, in order to figure out whether or not an argument is valid or invalid, okay, using a truth table, what you want to look for is a line, at least one, where the premises are all true and the conclusion is false. If you can find such a line, then the argument is invalid. But if you cannot find such a line, then the argument is valid. So let's look here. Here are the columns that represents the truth values, or the possible truth values for premise 1, premise 2, and the conclusion. Okay? So now looking at these truth values, notice that we have here one line where you have true premises, true, true, and a false conclusion. Okay? So you have a single line where you have true premises, okay, but you have a false conclusion. Okay? Because we were able to find this line, okay, that this truth table has a line, at least one, where you have true premises and a false conclusion, this argument is invalid. So logical analysis will tell us that this argument is invalid, okay? This line basically tells us that it is possible for this argument to have true premises and a false conclusion, okay? Because remember, each line is a possibility, okay? These are possible truth values that these premises can have. So here you have a case where it's possible in line 3 to have true premises and a false conclusion. And remember, a valid argument is one in which it is impossible to have true premises and a false conclusion. So if you have an argument where it is possible to have true premises and a false conclusion, it is invalid. Okay? We can also do truth value analysis on this argument as well as analyze the argument as a whole in terms of soundness. Okay? So let's go ahead and do that. So premise 1 states, if Socrates was human, then he was mortal. Is this true or false? Well, is it the case that it's possible for Socrates to be human being true, but him being mortal being false? No, it's not. Okay? So this statement, if Socrates was human, then he was mortal, is actually true. Okay? So we have here, premise 1 is true. Okay? Now, here's premise 2, Socrates was mortal. Is that true or false? it's actually true, Socrates was mortal, okay? So premise 2 is also true. Okay? So notice here we have a case where the argument is invalid. The reasoning of the argument is poor. The argument does not give you reasons such that if the premises were true, the conclusion would definitely be true. Okay, so it is invalid. However, the premises are both true. Okay, so you can have an invalid argument with all true premises. Because we have here an argument that has all true premises but bad deductive reasoning, this will be an unsound argument. Okay, so we've gone from an argument to translating it into propositional logic to doing a truth table for that argument in order to determine the validity of that argument. And then we've also separately done truth value analysis as well as determine the soundness of the argument as a whole. Okay?